Welcome to the session on application software overview covering DNA, element management system and Xceed SDN platform. Today's topics include an overview of the Infinera Management Suite products, DNA with its architecture applications, Xceed the SDN controller with its applications and architecture. Infinera Management Suite is a set of products enable network management and automation for end-to-end Infinera portfolio. It consists of local node manager called the graphical node manager. This is an embedded node management application which is bundled with all network elements of Infinera. The digital network administrator is the management software for the element management and network management of Infinera portfolio. Xceed controller is the SDN controller enabling automation and SDN applications for the Infinera optical networks. The cloud automation toolkit is a bunch of network element interfaces enabling back office integration and OSS automation for the networks. The network planning system supports end-to-end network planning and design for the Infinera long haul and the metro network elements. Getting into DNA, DNA is a client server based system. The key technologies that enable a carrier grade network management through DNA is network as master, where all network element data is treated as the master and DNA responds to every change in the network in a real-time fashion. This enables multiple DNA servers to manage a single network with geographical redundancy. The auto discovery of the network element supports single click discovery of entire network into the digital network administrator. It is a client server based architecture running on Linux based physical or virtual system. It supports databases either on MariaDB or Oracle database. DNA supports up to 100 concurrent users and has been certified for more than 500 administrative domains, scaling up to 7,000 network elements with historical storage of more than 3 months of database with the standard architected server. DNA is built with security from the basic. It has security at all levels. All communications between DNA and all components within DNA and between DNA and network element is secured. DNA uses secure protocols to communicate to network elements either via SSH or TLS. Between DNA server and DNA client, HTTPS and TLS are used to encrypt the communication. Between DNA and NPS, there is secure file-based communication. DNA supports role-based access control with user privileges that control what access is available for a given user. And these user privileges are predefined starting from monitoring access, which is a network view read-only access, security administrator to administer DNA and its security aspects, the network administrator who has the ability to administer entirety of the network, and then other bunch of operational roles like network engineer, provisioning user, test and turn. So all of this provides a fine-grained model to enable role-based access control for various users. System also supports Radius based and TechAx Plus based centralized user management so that there is single user repository to authenticate both the node manager and the EMS. DNA is, has powerful single screen applications which enable a specific network operation center workflow. These applications collect all relevant information in a single screen to provide achieve an end-to-end goal of a given operation. And element of providing single screen application is carried forward from service fulfillment to service assurance use cases. The digital link viewer is an application that provides line side diagnostics for an end-to-end Infinera line system. This provides graphical view of connectivity of the line system, the optical power management at each point in the link, the optical power performance management counters, and initiating various troubleshooting options, including collection of debug logs on this application. So this acts as a single application to diagnose any fault on the optical line system or even turn up additional super channels in the line system. The optical bandwidth manager is an end-to-end application tracking spectrum utilization in a flex ROADM network. This provides graphical visualization of spectrum utilization between two ROADM network elements with clear indication of the optical circuits that are being used. Circuit Diagnostic Manager is the diagnostic application for the layer 1 circuits. So it provides an end-to-end view of a circuit from tom to tom, including all the facilities and all the line system equipments that it traverses through. It provides ability to perform diagnostic operations like TTI, loopbacks, and so on. It also collates the fault state, the admin state, and the service level performance counters in a single view. It can expand and provide a list of circuit layout record, which is a tabular form of the circuit path, which can then be used for any offline processing. The other applications, workflow-based applications, include A to Z provisioning, which leverages the underlying GMPLS and provides constraint-based A to Z drag and drop provisioning for client services. The digital bandwidth manager tracks the layer 1 OTN bandwidth utilization and provides to granularity of 1.25 gig the utilization of various bandwidth between two digital network elements. And this is a key application used by network planners to place new services and reserve capacity for future expansion. DNA has strong integration with the network planning tool, which is the NPS, and this provides an end-to-end plan to provision workflow for the customer, where the user can plan the network offline using the NPS tool, then exports all planned data, planned and designed data, including the optical engineered light path, the optical circuits, the digital circuits, if there are passive equipments, all passive equipments and their connectivity. All of this can then be brought in through DNA with an application called Plan to Provision Manager, and then provisioned on a single click, where the design is seamlessly transferred into the network through serial orchestration via DNA. This completes an end-to-end plan to provision cycle where the user can plan in NPS, provision in DNA. The network data can then be re-imported into NPS for further brownfield planning. This solid integration between planning and management system enables bulk and quick turn up of network. Some of the network service assurance applications include the digital link viewer for optical link diagnostics, the topology map, which is auto discovered complete topology from the Xceed node, with multi-layered topology where there is a physical view and also the provisioning view for layer 0 and layer 1. The fault information is propagated onto the topology, so any alarms in the network is clearly visible, and all applications can be launched context sensitive from the topology, be it drag and drop provisioning wizard or inventory for a certain portion of the network, and so on and so forth. Circuit Diagnostic Manager provides application for troubleshooting layer 1 circuits. So if there are faults on a service or a service alarm, this application helps pinpoint the location of the fault and then figure out further troubleshooting actions to troubleshoot and resolve the issues. DNA is a Java Swing based application with powerful user interface. Going forward, we are migrating that with all best-in-class applications into a forward-looking best-in-class technology. And the new application would be based on HTML5 and provide unified user experience for all Infinera management applications. This could be DNA element management application or the new SDN applications or even the node management applications for forward-looking platforms. The technology enables multi-platform support, which is basically all browser agnostic, the operating system agnostic, and when ready for multiple form factors in future like a mobile or a tablet rendering. It's designed with customization in mind, where user will be able to customize the home page with the dashboards and the widgets that are most applicable for them, provide a glance of the entire network when they log in. And the applications will be built in a plug and play fashion, where there will be modular applications that can be built and installed and get activated on this new web client. From an OSS integration perspective, there are a variety of interfaces available for integrating into traditional OSS interface. DNA offers an SNMP based fault integration server, which can integrate into Netcool and other fault management systems for providing alarms and events. The command line interface for exporting the network inventory is available in DNA. The network elements have open SNMP v3 and TL1 based interfaces to achieve end-to-end CAPS integration into OSS. These interfaces are driven from industry standards and are integrated into a variety of third-party OSS. DNA and network elements are certified with IBM Netcool for fault management, they're Telcordios Mine certified, and have history of being integrated to variety of OSS systems in different uh, applications. Coming into Xceed, Xceed SDN platform enables future SDN applications for our customer. So Xceed is built with open interfaces as the foundation scheme. Xceed platform has an abstraction layer which abstracts the underlying network elements and provides device agnostic uh, interfaces for Xceed applications. The Xceed applications are providing use case based automation for network provisioning, network planning, and advanced management applications. So the Xceed suite combination of the platform and the applications exposed via standard APIs enable next generation automation for optical networks. Xceed is built for Infinera network element with an open architecture which can evolve into supporting additional future network elements as well. Xceed has an inbuilt multi-layer path computation engine which supports service optimization across layers to provide an service realization with layer 2, layer 1 and layer 0 services. The Xceed application suite consists of dynamic bandwidth or bandwidth on demand applications for layer 0, layer 1 and layer 2, which covers the Infinera portfolio from metro, long haul core. So they provide standard APIs, IETFs or TAPI based REST APIs for orchestrators to activate and modify services of various layers. The automated capacity engineering is a network planning application suite which enables capacity planning or capacity addition on an existing network. This allows for reserving and activating capacity on flex ROADM based network and activating them on demand as and when they are required. Instant Virtual Networks provides network partitioning and partitioned service management use cases to allow customers to offer VPN kind of services. Instant Network is unique in Finera offering, which leverages the instant bandwidth concept on the network elements. Instant bandwidth is software defined capacity which enables additional capacity based on software licenses. The instant network application combines the planning capabilities of Xceed uh, and the instant bandwidth on the network element to provide a user capability to exactly define and activate capacity as and when they need without additional time involved in planning and activation cycle. From an API perspective, all of the SDN applications are exposed consistently through REST based interfaces which are following ONF TAPI standard. And these interfaces cover topology involving retrieval of topology of all layers, same interface providing API for layer 0, layer 1, layer 2 and physical topology, connectivity service involving provisioning of was unidirectional, bidirectional, point to multi-point services, notifications for alarms and attribute change of the inventory, path computation to compute a path which could be layer 0, layer 1 or layer 2, and an extension to provide equipment inventory so that comprehensive network inventory is available on the same interface. Xceed Dynamic Bandwidth Layer 0, Layer 1, Layer 2 applications provide programmability for optical circuits, OTN circuits, and MEF-based Ethernet services. They support end-to-end service fulfillment automation, includes discovery of layer topology, service provisioning, and for Layer 2 services, they enable dynamic restoration and optimization where SDN controller monitors the network for fault and restores on failure. The multi-layer PCE inside the Xceed platform is leveraged for providing an optimal path across the network. Xceed Instant Virtual Networks provides an ability to partition the network and hence provide an option for the service providers to expose services like VPN. Within the partition, it provides APIs for service creation and service management with constraints as defined by the user. From an end customer perspective, it provides full multi-layer visibility and each IVN and the instance of the PCE within the IVN allows for optimal path identification. From a service provider perspective, it provides easy way to offer differentiated services and tailor them for individual customer demand. Xceed is widely used in many of our customer in terms of uh, evaluating their SDN option. Some of the key reference use cases are around bandwidth on demand style applications with Telstra and Windstream for layer 1 with the some of our one of our UK operator pro evaluating a layer 2 service automation with including programming of their layer 0 ROADM network. That concludes the presentation for today. For further reading, you can reach out to Smarter and the sections of Infinera Management Suite and Xceed Software Suite for more reading materials, including executive presentation, deep dives, and recordings of the individual application demos. Happy learning!